I hate when they do that. I'll take your junk.
Yeah, no, it's a sort of, it's a game they play. Okay, now then, what we're going to do now, we're talking heat and AC test, and this is electrical stuff, pretty much, and inputs and outputs and that kind of thing. One alternative that best completes the statement or answers the question. This one right here. Which of the following is the unit for electrical pressure? Is it ohm, amp, volt, or watt?
Ohm's resistance, I know that.
Okay. Anybody know? That's volts. That's actually volts. Volts is the pressure. Believe it or not, that's volts.
What exactly is a watt?
A watt is volts times amps.
Oh, okay.
Got that? So you can figure out your watts if you know your amps and you know the volts that's available. You can basically come up with, you can do math to figure these measurements out. It's not that mysterious. But we talk more about that in electrical systems and stuff. But you have to know electrical if you're going to fix anything on a car. And while you probably won't ever use Ohm's law in the field, you still need to understand it so you're not totally dumb. Write T if the statement is true and F if the statement is false. Now, this is not rocket science, is it? Most automotive electrical systems use AC current.
That's false.
All of them do.
AC current?
All of them AC. Everyone else.
Don't.
He's making that up. You got AC current coming out of that battery? Now, let me ask you this. On the hybrid vehicle, the compressors that don't have a clutch and don't have a belt and just have an electric motor inside of them that drives them, they use AC. But does that AC come right out of the battery? No, it's got to go through a converter.
Don't some of them have DC to DC converters?
They do. They got a DC to DC converter
I don't
on there.
understand that.
Yeah. The reason is think about this. Think about what you're doing here. What you want to do is you want to be able to charge your battery and power up your gauges and all the stuff that you normally have on the car, but you don't want to do it with 330 volts.
Okay.
So you take your 330 volts, you run it through a DC to DC converter, it comes out. It goes in 330, comes out 12.
Okay, that's what that's all it
That's all there was.
I didn't know it converted it down.
Yeah, but actually it's a transformer, is what it is. But they call it a DC to DC converter. One of those things for a Toyota Highlander is $10,000. So $10,000. If you can, there's a problem with those. They could probably be repaired, but I mean, they had to be replaced every now and then. Choose the one alternative that best completes the statement or answers the question. See, they got these all mixed up. A fusible link is usually 4 sizes blank than the wire in that particular circuit. Larger, smaller, either A or B, neither A or B. Now, when we talk about a fusible link, and I don't have one here, I had a fusible link in my drawer that I was going to show you guys. Maybe here somewhere. I don't know. But a fusible link is actually got Hypalon insulation on the wire. It's going to be a soft wire that's got Hypalon insulation on it. And the wire on the inside of a fusible link is going to be a silver color rather than the copper color. And that wire will carry more current than a regular wire. Now, occasionally, what you'll wind up doing when you try to buy a fusible link, they may try to sell you a fusible link that's got Hypalon insulation wrapped around a regular copper wire, and that just doesn't work.
That's kind of crazy stuff.
Because if you try that, now why would that wire need to be smaller than the other wires?
So it'll break.
So whenever you got a current overload, it's not going to blow like a fuse, but if you got a strong current overload, it stays there a while. It's going to open up, and that's what that's for. It's going to be smaller. Okay, that's number 3. It's going to be smaller. Okay, which of the following is considered an output device in automatic temperature control systems?
An output device?
Yeah.
The blower motor.
What else?
Also,
compressor, clutch, and blower motor.
Also.
Yeah, 4. That's going to be C. In any computerized operational system, in other words, if it's a closed loop system, automatic temperature control is a closed loop system. Remember we talked about that before? You know what closed loop means? You guys know what closed loop means?
Closed loop or
It's not open. It's like a circulatory system, how some are open like a clam or a mussel, and then some are closed like humans.
Well, I'm not exactly sure that's what I was looking for. Your automatic temperature control does turns on the blower and the AC compressor based on what it reads as the temperature in the car. See, your blower motor typically on an automatic temperature control system, and since we're talking about AC, I'm going to go into this in a bit. All right, you got a blower motor here, and it's got, and it's actually feeding all the ductwork and everything. But right here on the dash, you might have noticed there'll be a little bitty screen-looking thing, and behind that, there's a little temperature thermistor that's wired to the temperature control, and this little pipe is going in here in such a way that where when that blower motor turns, it pulls air from inside the car past that temperature sensor, and it uses that temperature sensor's reading to determine is the temperature in the car equal to what the person has set it on. So the feedback is this right here. The feedback that's coming from that is this little sensor. Now on the Volkswagen cars, they have actually got register temperature sensors. You know how we stick a thermometer in the register to read the temperature and see if the air conditioner's working? That's built into a Volkswagen. And so you can actually look on your scan tool and see what the automatic temperature, what the temperature control is seeing for register temperature and all that. So that is a feedback loop. And the way that it loops back your module, so here's your compressor clutch, and I'm drawing them close together. It actually feeds an output to those two based on the input it gets from that and based on input from your knob. Whatever your knob is telling it. It's going to take what you send from your knob, compare that to this, and if it needs to cool or warm things up, it can also open the blend door. See, there's all kinds of cool stuff that ATC can do. All that temperature control. All right. But anyway, that's a closed loop system because it's able to watch that and modify what's going on to make it match, and that's the fun. Now, like I told you before, this watch that I'm wearing is a complicated piece of machinery, but it's not a closed loop system. It does not know if it's right or wrong. If it's an atomic watch that can read that atomic clock up there in Colorado or wherever it is, that signal, it is a closed loop system, and it always sets itself. Okay, now then, let me ask you this about wires. Have you ever noticed that the gauge numbers on wires, on metric wires, get bigger as the wire gets bigger, and they get smaller as the wire gets bigger on American wires? Mm-hmm. You know what the numbers on European and metric wires are? They actually are millimeters. If it's a 1.0, it's a 1 millimeter wire. If it's a 2.0, it's a 2 millimeter wire, which is a bigger wire. Well, on imperial gauge sizes like we use, the smaller the number, the bigger the wire. 10 gauge is huge, and then it goes down from 22 gauge is little, and it goes on down something like that. So the gauge numbers go opposite directions. That's kind of like your thread pitch on your metric bolts. Now, on an American bolt, it's how many threads per inch, and on a metric bolt is how much distance there is from crest to crest on the threads. So the numbers go opposite directions. You see. The bigger the number on the metric bolt, the coarser the thread. Right. But the bigger the number on an American bolt, the finer the thread. So that's just really interesting how all that works out. Say, which of the following is an output? There you go, both of them. Which of the following is monitored by a sensor in the AT system? Ambient temperature, sun load, in-vehicle temperature. All of these are monitored. Every one of them. Sun load sensor is going to be something kind of like what I've got here. If I can find it. I have a little, somewhere in this box here. I got to locate that. I'm not going to dig for it right now, but it's in here somewhere. Anyway, here it is right here. Never mind. This little thing right here, and you can buy these at Radio Shack. See this little thing right here? That little thing right there is an electric eye. All right. Now, it changes resistance whenever you change the light that's hitting it. All right. Give me that meter right there, Brandon. That little meter. And these right here are found all over our cars now. They need to know about the light. What's something you can think of off the top of your head that all of our Chevrolet trucks use this for?
Turn on lights?
Huh?
Turn on headlights?
Yeah, they do that, or they turn on the doggone daytime running lights, whenever you get out there and you got it to drive. All right, now watch this. You guys see this meter? All right, come here. I need another set of hands. Come here, Sean. All right, now you notice right there. Hold that so that the people and the camera can also see that. Okay, you see what I'm measuring there? All right, now watch when I cover it up with my fingers. See it change? Now that is not just a switch. I can actually partially cover it up and it changes a little. See that? So see, it's basically looking for light is what it's doing. That's what you're after. Got that? All right. What a lot of people don't know too is on your remote, if you point it at the camera, it can actually see the light. See that? Barely can, but it can see it. Let me see if this one shows up better. That one maybe had a dead battery. It is. Can't see it. That's it. I'm out of remotes. I can't demonstrate that. I demonstrated it a little. You can see it on that other one, but it's real faint. Okay, so everybody remember that. I'm going to pass this around. I need it back because I'd have to go hunt for another one at Radio Shack. They don't cost very much. But you got to have some really sensitive stuff. Make sure it gets back in this box whenever we're through looking at it. You can, whenever you look at that, look at the top of it and study it, because when you see one, you need to be able to recognize it. You may see a little something in the dash. It may have a little dome over it, but when you look down in there and you see that little grid-looking deal on the very top, that's what's looking for the light. Okay, is this the true or false question here? Electrical mode doors in the automatic temperature control system usually have a feedback sensor string connected to them. That is a strangely worded question. A feedback sensor string. I don't like the way that's worded. If you're going to get that one right according to the answer key, and I don't know, I mean, that's a strange thing. Like I said, I don't know if they're actually talking about that. But do any of you guys know how that feedback works on your automatic temperature control doors?
I've never had them.
All right. Well, let me tell you this. You know how I always think about that? If I was going to build something from scratch, my computer, my automatic temperature control computer, needs to know where that door is. So it can know, and it also needs to know where the stops are. Okay, so if you've got a door, you're going to drive this door. See, this door right here is going to be connected, and it's going to be moving in its housing. And it's only going to move so far. It's got stops on either side of it. And, you know, let's say that it's going to let some air in from here, and I'm just making a generic drawing here. Or it's going to, and it's got air coming in from over there and all that. So if you're going to move this thing back and forth, and you got an electric motor driving it with this box right here, right? You got the electric motor driving it. All right, now you're going to have this door. First thing it needs to know is where the stops are.
How does it know where the stops are?
Whenever you first put it in there, on a lot of these, and there's various different ways that they do this, it's going to sweep all the way over there. It's going to sweep all the way over there. And then it's going to remember those.
Oh, yeah.
But it has to have on it, typically, and this is a typical arrangement, you know the throttle position sensor you're used to?
Yep.
All right, you're going to have two wires coming into this thing. It's going to operate your little motor.
Mm-hmm.
There's going to be some electric circuits in here. And there's a wiper on here. And you're going to have three more. And this is basic. Now there's some other I'm going to show you later on with the Chevrolet truck.
So it's just like a QPS.
Huh? Very similar. Yeah, you're going to have a wire there and a wire there, and then this one here is actually going to be connected to that one. So as it wipes up and down, so you got 5 volts here, and you got 0 volts there, which will be a ground, and this signal going out is going to go change with door position. Mm-hmm. So it's watching that while it's using this to drive it back and forth. Right? Now the cool thing about it is, and I can show you this on these Chevys, you actually have a way of, there's some little wires plugged in here. You can actually jump on one wire to the other and make the thing go back and forth while you read the stuff. And I need to show you that on GMC. It's cool as all get out. You can pop the right-hand side of the dash off. You can find the connectors right there to go to those actuators. And standing right here by the dash, you can drive those things back and forth and watch your motors and tell what's going on. Really cool. All right. If you understand what you're doing there, and we'll get into that at some point, before we're done here. We'll talk some more about that. We got to make sure we burn that in. One of the things you guys got to get away from is this business of I've done this once and now I've done it. I don't need to do it again. I may have you repeat the stuff that you've already done so you can burn it in.
Yeah,
that's kind of special topic to say, but I got a question.
Nope.
Because it's getting on my nerves.
Oh well.
On my truck, when I stop, it's vibrating like crazy. Is that because the tire's out of balance?
Are you feeling it in the brake pedal?
Oh yeah, and the steering wheel too.
You're going to be probably need to machine your front rotors, and that will take care of that.
I'm just wondering if it's driving me nuts.
Yeah, it would. It's annoying. My truck was doing that.
Yeah, I did it one time. I slammed on the brakes. It made me smack, stood in part, and got out and kicked it.
You did? Did it care?
Probably.
Yeah. That was probably pretty funny to watch. Okay, which of the following instruments can be used on any automotive electrical circuit?
Number 6.
Electrical mode doors usually have. They put a true there. I mean, I don't like that string business. I don't like that string. I don't know what in the world that is. Sensor string. What in the world is that? I don't know.
It means there's like a daisy chain system of them.
I don't know about that. I do know that on those Mercedes cars, some of them have 8 or 10 actuators under the dash, and they're all daisy chained together with a network kind of thing. Never fails. The phone always rings while I'm teaching. All right. Okay. Let's see. Which of the following test instruments can be used on any automotive electrical circuit?
C.
Huh?
C.
A B?
C.
Oh, the C. Digital multimeter. Modern electronic circuits being damaged by rough handling, electrostatic discharge, excessive, any of those, right? Okay. Which of the following is true concerning ohm meters?
C.
Can they do that? 9.
Which of the following?
Ohm meters are self-powered. Yeah. You know, ohm meter's got to have a battery in it before it's going to work. What does it do?
Oh, yeah.
Yeah, it puts a little bit of current through it. Now, something else you're never supposed to use an ohm meter on. Let me tell you this. This is really interesting, too. If I've got a ground wire going from the engine to the firewall, and I'm just going to check from there to the firewall, then am I going to get an accurate reading with the battery connected? No, you won't. And the crazy thing about that is if you don't disconnect the battery, even though you're not even connected so that it seems, but if there's any current whatsoever flowing through that wire with the battery connected, it's going to screw your reading all up and you're going to get 40, 50, 80 ohms, whatever. But if you disconnect the battery, that is a reliable reading. So anytime you're doing any ohm testing, particularly from the engine to the body or whatever, you need to make sure that you've disconnected the battery or you're not going to get a good ohm reading. Now, you got to have the battery connected if you're going to check volts, unless you're checking AC volts from a spinning sensor or something. Okay, now, the other thing that I wanted to say about that was that if you are using an ohm meter to check the veracity of a ground, you're probably not going to get an accurate reading there either. Let me hit you with this. If I've got a battery cable and I have ground that battery cable away so that there's only one wire still holding, like if I took it to the grinder and if I ground that battery cable away and there's one wire holding, I'm going to check it with and I'm going to tape all that back up where you can't tell what I've done, right? And you measure it with an ohm meter. Are you going to read a good reading with your ohm meter? You will, because one wire. Is that going to start the car? No, it's not, because the current flowing through that little wire. Matter of fact, it's probably going to heat that wire and burn it too. But or you're going to have, if you got a little tiny few wires there, it may have real slow, a lot of voltage drop there. Well, the fact is, you better have something that's going to pull some current. Checking that with. So get you a headlight bulb, look at the hot side of the battery. If you're like, for instance, if you're checking to see if there's a good ground between here and whatever, you're going to check it, take your headlight bulb that pulls about 5 amps and hook it up to the hot side of the battery and check it with that. Check it at the battery first, it burns bright. You check it on that ground, if it burns dim, then that ain't a good ground. But if you checked it with a dadgum ohm meter, it's going to check this fine. You see where I'm going with that? All right. Now then, it's really important to recognize that. You understand that, don't you, Brandon? He's picking his teeth over there. When he's picking his teeth, he can't think clearly. Okay. Modern, let's see. Which of the following, a rule of thumb for clutch coil resistance is what? 3 to 5 ohms. Clutch coil resistance, 3 to 5 ohms. Okay, a vehicle with an automatic temperature control system has heater and defroster operation, but the AC is not working properly. To diagnose this problem, the technician should do what? It's automatic temperature control now. You can check for trouble codes. On some of these Cadillacs, you could even check for your engine. You had a scan tool built into the dash. You could hold a couple of them buttons off and warmer or something, and you could actually go through and cycle through and read your throttle position, voltage, and all kinds of crap right there on the dash on the Cadillac.
We had to do that with
kind of the refrigerant went low in one,
Yeah,
and you had to do all that.
yeah, the code thing. And Michael eats that kind of stuff for lunch, don't he? He loves it. Yeah. All right, so an example of a short circuit is what?
All of them.
Wow, well, not really.
Hey,
Hey,
Yeah. Now, I'm looking at 12. Actually, what in the world? This is really a crummy question. A burned wire with bad insulation that touches ground. That sounds to me like a short circuit, don't it, to you? A burned out light bulb. No, that's an open circuit. What they're wanting you to say is a clutch coil with a resistance of a half an ohm.
why?
Well, that is going to blow the fuse, but this burned wire question, this answer up here, the first, is a bad answer. But if you want to get that one right, put B. And I'm going to go on record with the textbook publisher saying that is really a poorly worded question. Now, I'm going to tell you that typically you won't find that on ASE tests. In other words, you won't find questions that are poorly worded a lot. Sometimes you will, but there's not, if you're going through there, sometimes I've seen some of the tests in these books saying, oh my God, son, who wrote this test, And that one right there has got a bad answer. 13, the blower motor runs on high speed only. What does that mean?
resistor bank is faulty.
Well, listen to him.
Well,
Bad resistor, because they don't go through the resistor on high. If it bypasses the resistor on high, and that's the only one that'll run on, you got a bad resistor bank. Now, these resistor banks have also got a little thermal resistor, a thermal fuse built into them so that if for some reason there's no air flowing, the newer ones do. You remember the one I showed you guys the other day? This one that I liked, that it was so easy to understand because it's got all those little spring resistors on it. That one didn't have a thermal fuse on it. But sometimes when I was at the Ford place in Dothan over there, I would find one on somebody's car that would have a blown thermal fuse. And the thermal fuse on that thing, I wish I had one here to show you, and I could probably come up with one later. Usually the thermal fuse is clamped, and it's like this right here, and it's going to look like that. And it's actually going to be clamped to a couple of wires so that it's fixed so that if that thermal fuse gets beyond a certain temperature, it's going to open that circuit and your blower is going to be completely dead. And all you needed was another thermal fuse. And believe it or not, I used to go to Radio Shack and buy them dadgum things. And it'd be $1. And I'd go at lunch and I'd pick up a thermal fuse, and if I had a customer that was under the gun and needed to go, I'd come back after lunch and I'd bend that thing. I put some little heat sink devices like, alligator clips with grease in them on there so that no heat could get to this, and I would solder them back in there and put them a thermal fuse back in there, and they'd be good to go. Which is pretty cool. Now, that's not a directional thing. It'll go either way. It'll work. It's not like a diode,
How much would you charge them to do that?
Huh?
How much would you charge them to do that?
Oh, wasn't very much. It's whatever. We usually charge an hour, basic charge to check one. And if they could get by with that, There was this woman on this Taurus one time that like a mid-90s Taurus, and the speedometer needle was just bouncing all over the place whenever she'd get to a certain speed. And I had on my Taurus taken the speedometer out of there, popped the needle off of it, and of course she raised the needle over the little bottom post and let it drop down so that it's got a little mark that it points at down there, so you can tell where the base is for that. Anyway, I take a little forked tool that I made out of a screwdriver and pop that needle off, and then I take the speedometer apart, and that needle had a drum. There was a drum that was driven by a magnet. It was a drum like this, and the needle was hooked to that, and there was a real weak spiral spring there that was holding this needle down towards zero. All right, and this magnet, this thing rested in this little bushing in the center of this magnet that would spin inside that drum, and the speedometer cable was hooked to that magnet, and as that magnet spun, it would drive that drum against that spring pressure. But what was going on was this little bronze bushing that this needle shaft was sitting in was kind of dry, and it was causing it to catch and all. And so what I do is I take all that stuff apart, and I get this little needle shaft socket in my hand down there that's in the middle of that magnet and blow that out, and I put one little teeny tiny drop of motor oil in there. And it would stay there because it was such a tiny little plate. This thing was like the size of a pin, a straight pin, I put it all back together, and man, that thing was so smooth. Bottom of that shaft swimming in oil. Well, if if she had a speedometer head replaced on that thing, and we'd seen this before, replacing a speedometer head on that car is like $500.
Yeah.
But see, I would do that job, but pull the speedometer out, take it apart, fix it, put it back in for like an hour and a half. You know, and it would get them going without them having to spend a fortune on it. You know? And she had called me out there, and she said my speedometer's bouncing everywhere. And I said, well, you know, if we put a speedometer head in there, which is what we're supposed to do, you know, it's going to cost a lot of money. She said, well, I don't have to spend $400 or $500 on that if I can get out of it. I said, let me try this. No guarantee. Let's see what happens. It was just perfect, you know. And I did a bunch of them like that. I fixed my own car like that. I put a speedometer on my car under warranty, and it started doing it again 30,000 miles later. And so anyway, I went ahead and fixed mine that way, and it's, you know, still floating. Anyway, that's the long and the short of that. So a lot of the time, you know, one of the things you don't want to jack around with, though, and I told you this before, don't patch anybody's cruise control because you may crash and burn on that. Don't patch anybody's airbag. You know, don't do anything out of other than book procedures on airbags, cruise control, or any of the safety related stuff. You know what I'm saying? You know, anybody's you don't want to do no second rate patch job or anything really. But occasionally, if you can bring it back to factory specifications in a way that makes sense, it don't hurt a daggum thing. Some of these fuel pumps, when they first started putting electric fuel pumps on cars, they would make them run on less voltage by putting a resistor wire or a resistor in there, and if the pump wasn't running as fast, it wasn't as noisy. People didn't like hearing that humming noise coming from the back when the first part put the pump on it. And so Ford put a resistor wire so that it would only run on 8 volts, which was, over time, that resistor wire would it would bypass that when you were starting it, and it would give it full 12 volts. But whenever you cranked it up, it's kind of like the old ignition coils, you know, it started on 12 and run on 8 or whatever. So I started taking that little fusible link that would feed the relay with a full 12 volts loose from the starter relay, because it's right there on the starter relay. And I'd put an eyelet on it and put it over with a big battery post. And so that way we always had good strong fuel pressure, because over time that resistor wire would get weak, the fuel pressure would drop off. You'd notice that it didn't have, but if you put 12 volts to it, it'd be nice and strong, so it wasn't hurting the whole thing. And so the shop foreman got angry about that. He says, you're causing us to have liabilities here. We're liable to burn somebody's car down and all this kind of thing. And I said, wait a minute. He said, you're going to have to show me in writing where it says that you can do that. And I said, well, I got to put a fuel pump on this one. I'll look it up for you when I get through. Lo and behold, I opened the box. And out of the box that I got the fuel pump out of comes a piece of paper, a piece of wire with a fusible link on it, and instructions to do exactly what I had already been doing for 2 years. It told me to do, and I said, there it is in writing right there. That's what they're telling you to do on an older car, is do what I've already been doing. See? Well, he was worried about the liability of it. He was afraid, well, there must be. But the reason they did that, he didn't understand, was because they didn't like the pump being loud. It wasn't because the pump liable to blow up if it gets 12 volts. Because they didn't want it to be noisy. See? I mean, see, there's nothing wrong with the repair I was doing. As a matter of fact, it was sanctioned by Ford, only he hadn't read about it yet. You see, but I kind of reasoned the thing out. The emission system stuff, by the way, you don't ever want to alter that stuff, because that's like $10,000 fine. You know, the EPA come after you, get you by the ear. So don't ever do anything on an emission system that's not in the book. You know what I mean? Now, I mean, I'm not talking about if you've got a split hose going to your evaporator, if you cut it and put it back on there. I ain't what I'm talking about. I'm talking about altering it somehow so that it's not effective. Even changing the dadgum idle speed. Turning a screw, they'll get you on that one. If it ain't in the book, they'll bust you. Yeah, boy, they'll get on you. That's good. Can't be worried about that. All right, let's go on here. Vehicle overheats because the cooling fan doesn't operate. This could be caused by what?
All of them.
Any of those. And I showed you before how to check a cooling fan motor. The blower motor stopped working on all speeds. Technician tested the motor touching a jumper wire from battery positive to the power terminal, and the motor did run. So he was able to power up the motor independently of the system that drives it on the car, and it ran. Technician A says the motor should be checked using a fused jumper lead to test for excessive current draw. Technician B says the resistor pack and the relay are likely to be defective. All right, and we talked about that earlier. C is both technicians. However, the resistor pack is not going to make it not stop working on all speeds. I mean, so I don't really like that answer either. Some of these questions, I'll tell you what, I need to talk to these people about this. Because we just got through talking about how the resistor pack is not going to stop it from working on high, right? And let me tell you this. How many of you know that usually your blower motor switch feeds ground to the blower motor and not power? Yeah, on most of them. There's power going to the blower motor all the time. It'll come from a blower motor relay. And all of these, the resistors is carrying grounds through there. All right, now then, a blower motor is drawing more than a specified current. Technician A says the blower motor ground connection could be corroded. Technician B says the blower motor is shorted. You see this fuse here, and I actually put the picture of this fuse on my Facebook page for Technical Writer. See that fuse? I keep this fuse in this drawer for a reason. This fuse is not blown, but it's burned up.
How'd that happen?
Well, we got a little current impedance here because it started to oxidize these terminals. And when it started to oxidize the terminals, they started to get hot. And the hotter they got, the more oxidized they got. And finally, this was for the fan on the car. The car was trying to overheat in traffic. We pull this out, it had actually scorched that terminal so bad that no current could flow, but it never had enough current flowing through here to blow the fuse. It wasn't because the blower motor was pulling too much current. It was because we developed resistance here. Now, number 2. Donnie tells me about a 2006 Malibu. Okay, the people call him and they say, my air conditioner has quit working and it's blowing the fuse going to the compressor, which is usually, the little clamping diode in the compressor clutch coil. It's got a clamping diode in there so that when you de-energize the compressor, it will send a spike back into the PCM and make a boom and all that. So that thing can go shorted, or the coil itself can be shorted, and it can cause it to pop the fuse. Okay, so this thing had been popping the fuse. Now, it would work a little bit, and then it would pop the fuse. So it was probably just a coil with some excessive resistance or something, which would require the replacement, possibly of a compressor. But you can get a clutch in a coil if you want to, Okay, long and short of it was, he says, have it here Monday and I'll look at it. Well, they never showed up on Monday. And when they finally did show up, they had took a piece of number 12 Romex wire, bit it into a horseshoe, crammed it down in there where the fuse went, and they overloaded that circuit so much with current that they fried the wire harness. Because the fuse was there for a reason, right? Okay, so he pushes the fuse down in there. He pulls that out and he says, look, I'm going to have to try to find you a wire harness. There ain't one. You can't even get a new one.
Wow.
They just don't make them anymore. 06, Malibu. Couldn't get a harness. He goes, now I can split this harness and I can open it up and I can go fix everything that's wrong with it. But that's M time. You know what M time is? You're going to pay me for how long it takes to do it. You're not going to pay me 2 hours and then what I'm saying? Because you may be working on it all day. So you may be paying me 8 hours labor, times $75 an hour or whatever you're getting there, $100 an hour. So this is liable to be really expensive. And the guy just figured, and also there's other issues that had happened because that melted wire that he had fed with all that current through that Romex thing had burned into other wires all through the harness. This made a disaster area out of that car. It was a nasty business. But see, the guy thought he knew better. He said, well, I'll just force this thing to run. And then he wound up with all these other problems. Yeah. Anyway, it went out of there on the hook, I guess. But one way or another, blower motor drawing more than specified current. Technician says the blower motor ground connection could be corroded. Is he right about that? Will a corroded ground connection make it draw more current?
Wouldn't it be less?
Huh?
It make it go slower because it wouldn't have as much current.
Yeah, so, of course, I will tell you that you will actually have more starter draw, whenever you've got low voltage coming out of the battery, the current goes up because of that. But anyway, you're right about this. It's not going to make more amperage with a corroded thing. Technician B says the blower relay is shorted. No, not really. So we're basically talking about an either technician there. Okay, which of the, let me see here. Let me see right here. Which of the following might be excessive circuit resistance? Short ground, weak battery, shorted motor windings, corroded switch. Always going to be a corroded switch. Current flowing through a circuit is measured in what? Watts, ohms, volts, or amps? Amps. The resistance of electrical flow through a component is measured in watts, ohms, what? Ohms. If a conductor has infinite resistance, it is what? Open. How many times have you heard somebody talking about my so-and-so has a short in it just because it comes and goes? Well, if the wire's in 2, that's not a short, that's an open. See what I'm saying? There's a difference between a short and an open. You got 2 wires touching each other, or you got a wire touching ground, that's a short. If the wire has been rubbed in 2, and it's just sitting here not touching, but every now and then, that's an open circuit. Technician A says most late model control systems allow the system to communicate with diagnostic test equipment. You right about that? Come on, guys. Deer in the headlights.
OBD2.
Technician B says most late model control systems can run pre-programmed system diagnostics and generate trouble codes. Both of those guys are right. Okay. What type of circuit is shown on number 22? What type of circuit is shown?
Series circuit?
Plain circuit.
Yeah, you got on that circuit that they've got illustrated there. You're actually going through a fuse. You're going through a switch, and there's a switch, and then you're coming through 2 light bulbs, and then you're going to ground. So everything, it's got to go through every bit of that before it goes to ground. So what is that? Series circuit. Okay, the other one is drawn this way. Got a light bulb there and a light bulb there, and they both share a common ground. They both share a common pair. That's parallel. All right. Okay, in this schematic, what will be approximate voltage displayed on the DVOM? In this schematic, what will be the approximate voltage displayed on the...
How can you possibly tell that?
Look at where you're at. You're from ground to what?
To the wire. I mean, it's
Yeah.
still. I mean, not enough information.
Is that sort of a spooky question for you? What do you think?
Is there going to be stuff like
That's
this?
number 24, right?
There going to be stuff like this on the ASC test?
Well, no, not really. This is a booger bear. All right, let me ask you this: if you've got now, look at your blower relay, right?
It's going to be battery voltage because it hasn't went through the resistor yet.
Now, wait a minute. If you turn that relay on,
Yeah. Okay.
say if you notice when you're on high,
How
huh?
much resistance is in these resistors?
Well, if you've got 3 of them, they're with, let's say they've got. How much you think they might have a piece?
3.
Yeah.
So I make
Now they may want you. There's not enough information, is it? But there would be probably if you read the book, you probably would have enough information on that.
If they had 3 resistors with each one of them having 3, that's 12 volts. You wouldn't have any.
Yeah. Well, I mean, if you've got 3 ohms per resistor, how much is the total resistance?
I don't know. I haven't.
Well, what's 3 times 3?
No.
9. Okay, so if you've got 9 ohms,
3
or how many times will that go in? In other words, how many times will 9 go into 12?
12.
Yeah.
1 and 1/3. No, 1 and 1/3. Yeah.
1 and 1/3. Yeah, I'm sort of like y'all. I think they sort of hoodooed us here with this. Now, like I say, there may be something in the book that gives you the answer to that, exactly like that. But the correct answer, according to the answer key, is A.
Hey.
Yeah. Isn't that something? Okay, let's figure this out. Wait a minute. Back up. Okay, we know we've got 12 volts, right? Okay, so we know we got 3 volts. All right. Okay, so if we've got 3 volts there, we don't know, of course, we really don't know that either. We don't know how many ohms we've got, do we? All we know is that
We got a digital voltmeter.
we got a digital voltometer and it's hooked up downstream of the resistor. And when that high blower relay is in its normally closed position, that's where the voltage is coming from that's going to run the motor. You might notice when you put it on high, see that little arrow when you move it all over to high? You're basically going to be directly energizing the coil on that relay, and it's going to pull it down. All right, now we wound up with a screensaver because I was there too long. All right, yay. We're just about done anyway. That was a funny thing. Now, I will tell you, when I was in Craig Van Battenberg's class, and I'm going to show you all that sooner or later. There was a bunch of stuff like that that you could tell by looking at it. And he says he would get everybody in the class and he'd say, how much voltage is at each point on this thing? He had A, B, C, and D. Write it down. You got 30 seconds. And so we had to write it down. Then he gave us one that's a little harder. Now you got 60 seconds to tell me how many amps is at each place here. And you could kind of figure it out if you understood current flow. And there was me and 3 other guys out of 16 that got all of those right. And everybody else had to go through the Army man thing, which would, I've got that stuff that I'm going to take you guys through. Okay, now then, in this diagram below, the blower is what? A, not running because the relay switch is open, B, running at low speed, C, not running, or D, not enough information. This is actually exactly the same drawing that we just looked at. Do we have enough information here?
Yep,
What does it tell? What is it?
it's on.
And it's
Going
running
through.
at, what speed is it running at?
Low.
Low speed. There you go. Going through every one of the resistors.